Hey everybody, it's Dave with Split. If you were at AWS reInvent last week and dropped by our booth, first of all, thank you very much. And second of all, sorry it was so loud in the hall and we didn't have enough amplification. So we decided to do a video so you could hear the whole talk and share this with others if you found it interesting, right? Now, if you remember, the top of the booth had a phrase that said, deliver features faster, skip the hot fixes and rollbacks. And that was kind of the promise of, well, why should you drop by and talk to us in the first place, right? And it turned out, I brought up this slide, it says the future is already here, it's just not very evenly distributed. And these things are related, which is that there are practices that very large companies have put in place that had very large tooling teams in order to gradually release software, limit the blast radius, and observe how well it's going, that they've had actually for a decade or more. What's new is that now you can actually just subscribe to that instead of having to build a giant tooling team and build it yourself, right? And that's what Split does. So this talk will give you a sense of what is this practice these companies do, and then how does Split implement that. So for starters, we're going to talk about something called progressive delivery. Now this term is actually new as well. This is about 1.5 years, 2 years old. It was coined by a RedMonk analyst. But the practice, again, is something that's actually been going on for a while, and you'll probably recognize it, which is that these companies that have a lot of users, they control the release of their software and they observe the impact of that software at the user level, all the way down to an individual. Not at a container level, not at a server level, not at an availability zone level, but literally one user at a time. So I'm Dave, so we're gonna release it to Dave, and we're gonna watch how it goes, and we're gonna add a few more people, et cetera, right? That's progressive delivery. Now, it turns out that these companies all pretty much solve this problem with the same 3 pillars in their in-house solution, right? They wanna manage the gradual exposure of software, they wanna monitor to limit the blast radius as they roll it out, and they want to experiment to be able to prove that the thing they're trying to move the needle on is actually happening, right? Experimentation is not necessarily, A/B testing and marketing and landing pages. It's literally, I'm an engineer, I'm trying to make something happen. Did this feature change we just did actually move that needle, right? So let's drill in a little deeper. Manage is really just about controlling the exposure of your code, right? So we want to decouple deployment from release. Deploying is just infrastructure, right? We're pushing code out to the systems. Release is when you expose it to users, right? So let's take a deeper look. So manage is about that control of exposure. And we might do this because we're trying to grant early access. The first group we want to grant early access to is our developers and our testers. We're in production. We want to give them a chance to actually test it one last time and make sure everything works as expected, right? But then we may roll it out to people that are contractually obligated to get an early peek, or we want to roll it out to our own employees and dogfood it a little bit before we show it to the public. Then we want to limit the blast radius. We want to start exposing it to larger groups of people out in the real world, right? And finally, we want to be able to define the surface area for learning. If you're going to run an experiment, it turns out the more people you run through the experiment, the more valid the data, right? In statistics, it's called power. Basically, more people. If you put 50 people through an experiment, you'll get some information. If you put 500,000, you get much more sort of bulletproof, statistically relevant information, right? So we want to define the surface area for learning. How can we control who gets exposed to this? And in that case, we want to make that probably as large as we can, but we're going to pass through limiting the blast radius first on the way there. So this is about decoupling deployment from release, and really more importantly, how do I decouple revert from rollback? We've all been involved in deployments, right? Where you roll something out and you hopefully have a recipe for undoing it. If something goes wrong, how do you revert and get back to sort of known good, right? And that might be a run book or something, and it might have an estimated time. We think we can get back there in 90 minutes or whatever. It generally doesn't go as fast as you thought, and something will come up along the way. And the worst case scenario is that one of the steps is reload the database, and the DBA says, yeah, we started reloading the database, but the indexing is going to take 12 hours, and we should be back online by 12 a.m. tomorrow. And now you're spending the rest of the night staring at your watch, hoping the system comes back up, right? So how do I decouple revert from rollback? Wouldn't it be cool if I could just flip a switch and stop the pain for my users right away and immediately have the system back to stable, and then resolve the issues behind the scenes with less stress and maybe not all night long? So the way we do this is with feature flags. And feature flags is just a function call in your code that lets you selectively decide whether that block of code should be executed for a user, in this case for Dave, right? So along comes Dave, do I show Dave this code or not? And what makes them special is that that feature flag, you put it in your code goes to production, but the rule set that's evaluated can be changed at runtime in production anytime you want. And it's not done with a new deployment. It's not done with pushing a config file. You'll have the ability to actually remotely control who gets it, how many of them, while in prod. That's basically why feature flags are different. Now, the first line you'll notice in there is 0%. So why would I deploy to 0% of my population in production? Well, there's basically two reasons. One is that your code isn't even finished yet, right? So if you're doing trunk-based development, you're supposed to commit to master at least once a day. And you're also supposed to deploy from master, right? Well, if it takes you 2 weeks to build a feature, you need some way for that thing to be off for at least 13 days, right? So you want to safely push code all the way to prod, but have it off, right? So that's one reason for the 0. The other reason is what we talked about earlier, which is giving the developers and the testers a chance to test in production before this rolls out to users. And when you know that 0% of your users are being exposed to this code, testing in production doesn't sound quite so scary, right? And from there, we're going to turn that knob up and down to be able to expose to more people or back it off. So let's move on to monitor. And the reason why monitor has its own slide is because monitoring in this world is a little bit different. And you'll see why when we take a look at the math. Remember, our goal for monitoring is to limit the blast radius, is to find problems early so that the problems affect fewer people and for a shorter period of time. Check out this quiz. If you roll out a change to just 5% of your population, and 20%, that's 1 in 5, get an error, okay? First of all, we could probably all agree that if 1 in 5 users is getting an error, I'm not gonna wanna deploy this out to more users, right? Not okay. I'm not gonna have a meeting to decide whether a 20% error rate is acceptable. It's just not gonna happen, right? So, but let's look at this. What percentage of your total population, if I'm going out to 5% of my users, and 1 in 5 is getting an error, well, that's 1%, right? What does that look like graphically? Let's have a peek. So, here's a sort of a graph in the knock of kind of the ambient level of errors that are happening, right? And there's that 1% is the red line, dotted line there. The reality is you're not gonna see this. At this rate, it's not gonna show up yet. And some people will say, well, it's okay because as we ramp it up from 5% to 10% and 20% or 50%, that red line's gonna rise up above the horizon there, we're gonna notice it. But think about it. If you could know that you were already hurting 1 in 5 users, would you ramp from 5 to 10% or from 10 to 20? No, you wouldn't, right? So how do we fix this? Well, it turns out that if you use the same system to control the exposure as you do to watch how it's going, solving this problem is quite trivial because it's pretty easy for this to watch that, right? So let's take a look at what happens if you have split. So here, the development team gets an alert saying, you're hurting people, you might want to stop, right? And in this case, the initial page load time is going out of whack, right? You might copy your on-call engineer with this, but you want this to go to the team that built the feature and the team that's rolling it out, right? Sort of you build it, you own it. And in a way, you can look at this. This is literally like the needle calling out from the haystack. Instead of something going wrong and people saying something's going wrong, we need to look around and spending a lot of time just trying to figure out what it is. This is the feature saying, hi, I'm being deployed, I'm out there, and I'm hurting people. Right? So that really changes the whole paradigm. And now we can focus on how do we resolve this instead of having a big long fire drill, right? So let's move on to experiment. And a lot of times when I mention experiment, engineers will say, well, you know, I'm not in marketing or I'm not on the growth team, so I don't really do experimentation. Well, here's the reason why everybody should want to do experimentation. At the bottom of that slide, it says, data informs the HiPPO. Who's the HiPPO? Well, the HiPPO is highest paid person's opinion. Right? Have you ever had a highest paid person's opinion in a meeting? Right? So it's a tricky situation where you have an executive who's trying to make a call. Their best role here is to break ties and to set a mission, but it's not likely that they know the technical details of something you're doing, right? And so by data informs the HiPPO, we mean, what if I could run an experiment? And I would try, I give some people exposure to something over here and some people a different thing over here and compare them and say, hey, here's what I found. Right? And then the HiPPO is going to say, that looks like we should go with that, right? This is how we reverse the flow. And it makes both parties happier, by the way. So let's take a look at what that means. Again, we're going to use feature flags. In this case, we're rolling out something to half of a population. And it doesn't need to be all your users. It could be 50% of your free users, or 50% of your 18 to 35-year-olds, or 15% of your East Coast users, or 50% of people that have been on the system for 90 days or more. Anything you want to do, right? As long as you know it, you can use that to divide up the users. And in this case, the team is trying to get users to create more tasks. They want users to create more tasks in the app. And if you look, they're doing amazingly here, 11.2% improvement in the number of tasks for the people in the new feature versus the old, right? Which is, you know, high fives, you know, even maybe you're gonna go on vacation, you're so stoked you got this done, right? And if you got that number by hitting the database and saying, you know, how many tasks now and how many tasks was it before the feature, or the people have it on or people have it off, right? You'd come back with this number and you'd be like, we're heroes, we're great. But what if this was also happening at the same time, which is that those people that go through the new version of the feature are getting 25% more latency, right? It's slower. right? Now, we know that 50 milliseconds is enough to drive people away from your app or your website. So if you're increasing a latency by 25%, you can be pretty certain that some bad things are going to happen while you're high-fiving each other about that 11% increase in tasks, right? So wouldn't it be great if you could just sort of automatically know this, right? Well, how do you do that? Are you going to have to check for everything all the time? No, and here's why. So there's a concept called a guardrail metric, and Split didn't invent this term. This term has been used by Microsoft, it's been used by LinkedIn. It basically means, a guardrail's on the side of the road and it exists there so that if you start getting a little off track, you bang into it and you kind of wake up and you don't go off the cliff, right? A guardrail metric is something that's automatically calculated all the time without the engineers having to put any effort into instrumenting it or following it, etc., right? So they're managing for tasks. Meanwhile, the system is watching response time because you as an organization decide that response time and errors and unsubscribes and other things you care about are things you want to monitor all the time, right? And as people are going through with this partial code exposure, you're tracking the difference between the people who are getting it and the people that aren't. And in this case, we know that the response time is much worse, right? And so here's a chance where the engineers don't have to exert themselves to track this. It's not a checklist. It's not a best practice for pair programming review. It's not a should, it's literally automatic, right? Otherwise, it's not a guardrail metric. So this is a dashboard in Split, and this is a dashboard for one feature, right? The team is rolling out one feature, this is what they're gonna see. And at the top, you see a section with those two boxes that says key metrics. And we see one's red and one's green, so we kind of have mixed results. Below that, you see a row of organizational metrics. Those are those guardrail metrics, right? So the team is trying to move the needle on the top two, and they're getting informed about the stuff on the bottom. And I mentioned it's mixed results for how they're doing so far, and they might want to iterate, but there's a really awesome surprise for them. If you look at the bottom left there, the server errors per user in their cohort is drastically lower than the people who don't have this feature turned on. So they're accidentally doing something amazing, something that would be kind of good news. So here's a dashboard, but we're going to want more data, right? Everyone wants a picture, they want a little more data. So you can drill into any of those and you're going to see the results over time for those metrics. And this particular square is actually for you're trying a baseline, which is the red line there, and two alternate treatments, right? And you can see that at the beginning, there's these kind of thick shaded lines, right? Those thick shaded lines are the confidence interval. It's how certain you are of the number that you're getting there, right? And they start out wide, and as you get more data, they get narrower because you have more statistical power, right? And here we can see that the difference between the baseline and the others, either of the alternates is great. You can then take this to the HiPPO. And the thing is, this is coming from a system that you already know and trust, and it's the same system everybody is using. This isn't a report you pulled out that says, hey, look at these numbers. This is the same system everyone uses if you're using this on your team, right? So there's a lot of power to be able to use this as a way to decide which way we should go forward, or to maybe iterate because the results might not be this good the first time around, right? So let's just wrap it up. How do I implement Split? It's actually kind of a 1, 2, 3 thing. First thing is you create a split. You create a feature flag on Split, and you give it a name, and you give it targeting rules. And initially, those targeting rules are going to be the devs and the testers, right? And then you may go add more people later. Those rules go out to a content delivery network. That's a network all over the world so that when the SDK comes up and pulls down a cache of those rules, it can get it locally very quickly, right? Now, so you put our SDK in your app. Why do you put my SDK in your app? Because you want it to run as your code in memory where you're running, right? Wherever that is that you're running. Front end, back end, doesn't matter, right? Once the SDK comes up and brings down a cache of those rules, you're making all those requests in memory. That app could be on a train in a tunnel with no network connectivity, and that decision is going to be made like that. There's no network traffic in order to decide which way to send a user through the code, right? Now, after you switch the user, this happens. We dribble out a little audit trail that says, hey, Dave came along and you gave him this experience because of that rule, and it was 223 when it happened, right? So now you have a data point that's who's the user, which flag did they go through, which way did you send them because of which rule, right? Then Split also ingests errors from something like Sentry or user behavior from something like Segment, or anything, frankly, you can post from with a little JSON snippet to a REST API that says it was Dave, it was this time, and this happened, or it was Dave, and it was this time, and he did this, right? That all gets ingested by Split, and that's when Split does its repeatable, reliable, rigorous thing, which is it does the attribution. These people went this way, these people went that way, and I compare the two, and I can say, you know what? There's a significant difference here. You ought to be aware of it, right? So now you're all caught up on how Split does this. And again, we're just implementing the model that's already been proven out there at very large scale by a number of companies. LinkedIn, Microsoft, Amazon, Google, they all have platforms that do this, right? You manage the gradual exposure of your code, you monitor to limit the blast radius, and you experiment to confirm whether the thing you think you're going to change actually changes the way you want it to. And you iterate. And maybe when you experiment, you find out that that you didn't really accomplish your goal in the first pass. And instead of just checking the box and shipping for ship's sake, you actually can iterate. And how satisfying is it when you iterate the second or third time and you actually do move the needle, right? This is why experimentation, by the way, not just for marketing people, engineers, quality of life thing, right? Thanks for your time. I hope that's useful. You can always find more information at split.io. Have a great day.